What if I told you that a massive, invisible force is already reshaping the Earth, and no one can stop it? It starts deep in the Pacific Ocean, but its fingerprints are everywhere. Floods, fires, failed crops, even wars. And now, in 2026, this force is returning. La Niña is back, and this time, the consequences could be far worse than we've seen before. Earth's climate isn't just weather, it's a living, breathing system, delicate, powerful, and deeply interconnected. From the burning deserts of Africa to the icy shores of Antarctica, everything is connected through invisible threads of wind, heat, pressure, and ocean currents. But sometimes, those threads tighten, snap, twist into something else entirely. And when they do, we see the signs: flash floods, mega droughts, coral reefs turning white, entire harvests failing, storms that seem to come out of nowhere. These aren't random. They're part of a powerful planetary rhythm known as ENSO, the El Niño Southern Oscillation. You've probably heard of El Niño, but its colder, often more destructive sibling, La Niña, is what we need to talk about now, because in 2026, La Niña is making a comeback, and it may bring with it a cascade of events we're not prepared for. In this video, we'll explore what La Niña really is, how it works, how it has shaped our history, and what it could do to Earth in the year ahead. Let's begin. ENSO, 3 letters that describe one of the most powerful climate forces on Earth. The El Niño Southern Oscillation isn't just one event. It's a natural repeating cycle, a swing between extremes, a pendulum of climate chaos and calm that begins in the heart of the Pacific Ocean. At its core, ENSO is the result of a tug-of-war between ocean temperature and atmospheric pressure. This cycle has 2 major phases: El Niño, the warm phase, and La Niña, the cool one. In between, we have what scientists call ENSO-neutral conditions, a relative state of balance. But that balance never lasts long. When the ocean heats up and trade winds weaken, El Niño takes over. When the trade winds grow stronger and cold waters surge to the surface, La Niña rises. And here's what makes it more than just a weather pattern. ENSO doesn't just affect the Pacific. It reshapes rainfall, wind, storm tracks, and temperatures all over the planet. From the Americas to Asia, from the Indian Ocean to the Atlantic. This isn't speculation, it's history. We've found ENSO signals buried in coral reefs, locked in tree rings, and layered in ancient sediments. Some of those records go back over 10,000 years, showing that this cycle has been influencing Earth's climate since long before the first cities were built. And now, it's swinging again. In 2023 and 2024, a powerful El Niño scorched the Pacific, fueled marine heat waves, and disrupted weather across multiple continents. That event has ended. And now, in 2026, La Niña is taking the stage. But what exactly is it doing? And how can something invisible thousands of miles away reach into your local sky and change everything? To answer that, we need to look at the invisible engine behind it all. To truly understand La Niña, we need to zoom out, far out. Imagine you're on the International Space Station looking down at Earth, not as a collection of countries and cities, but as a system, a single interconnected machine running on sunlight, air, and water. At the core of this system is something simple but profound. The sun doesn't heat the Earth evenly. Because of our planet's curve, the equator receives much more direct sunlight than the poles. This energy imbalance creates giant rivers of moving air, known as Hadley cells. Here's how they work. Warm air at the equator rises high into the atmosphere, carrying moisture with it. As it climbs, it cools down, condenses into clouds, and releases rain. This is why we see tropical rainforests straddling the equator. That same air then moves away from the equator, eventually sinking back down over the subtropics. Then the cycle repeats, rising, falling, moving, non-stop. But while Hadley cells move air north and south, there's another major system at play, moving air east and west. This is the Walker circulation. It works primarily over the Pacific Ocean and is driven by trade winds, steady air currents that blow from east to west near the equator. These winds push warm ocean water westward, piling it up near Australia and Indonesia. This causes cooler water to rise near South America, creating a massive system of thermal balance. But the key is this: when the trade winds change, everything changes. If the winds weaken or reverse, warm water sloshes back east, triggering El Niño. But when the winds grow stronger than usual, like they're doing right now, cool water surges across the Pacific, and La Niña begins. This isn't just a local phenomenon. These shifts in ocean heat and atmospheric pressure send signals across the globe, distorting jet streams, redirecting storms, and rewriting entire seasonal patterns. In essence, the Walker circulation is the heartbeat of ENSO. And in 2026, that heartbeat is pounding louder than usual. But what has this invisible engine done to our world before? What clues can the past give us about what's coming next? What we've seen throughout history is nothing short of shocking. La Niña and El Niño may sound like modern discoveries, but the truth is, they've been shaping the rise and fall of civilizations for thousands of years. Let's rewind history. In the mid-1500s, just as Spanish conquistadors arrived in South America, a powerful El Niño struck. Massive floods and crop failures destabilized the Incan Empire, weakening its resistance and making conquest far easier than it should have been. Nature, it seems, had already launched an invasion. Fast forward to 1789. Europe is in turmoil. A series of failed harvests, fueled in part by ENSO-driven weather patterns, leads to famine, soaring bread prices, and social unrest in France. Months later, the French Revolution begins. Coincidence? Maybe. But patterns like these show that ENSO is not just about climate, it's about consequence. Even in the modern age, ENSO continues to leave its mark. In 1997, an especially brutal El Niño caused $45 billion in global damage, from droughts in Indonesia to deadly mudslides in Central America. And most recently, between 2020 and 2023, Earth endured one of the longest La Niña events on record. That triple-dip event brought catastrophic flooding in Pakistan, displacing over 30 million people, severe drought in Eastern Africa, triggering a regional food crisis, unusually active hurricane seasons in the Atlantic. Each of these events can be traced back to shifts in the Walker circulation, shifts that started silently, deep in the Pacific. And now, that pattern is back. La Niña has returned in 2026. But will it echo the past, or write a whole new chapter? The answer may depend on what happens next, as we step into the core of the current event. In the vast silence of the Pacific Ocean, something has shifted. The winds have changed direction, the water has cooled, and now the world is beginning to feel the consequences. After months of warnings in early 2025, meteorologists confirmed what many had feared. La Niña had officially returned. At first, the signs were subtle. A drop in sea surface temperature near the coast of South America, a quiet strengthening of the trade winds across the equator. But by mid-2025, It was clear. This was no weak anomaly. This was the start of a full-scale, high-intensity La Niña event. According to NOAA and the World Meteorological Organization, we are now experiencing one of the strongest cooling trends in the Pacific Ocean since 2010. Ocean surface temperatures in the central and eastern Pacific have fallen by more than 1.5 degrees Celsius below average, a clear sign of an active and growing La Niña. And the models agree. This La Niña is likely to persist well into 2026, possibly longer. But what does that really mean? Here's the first thing to understand. La Niña isn't a storm. It doesn't have an eye or a name or a radar image on the evening news. Instead, it's a slow planet-wide distortion, a quiet shift in energy that ripples through the entire climate system. And once it starts, it's almost impossible to stop. During La Niña, powerful trade winds push warm surface waters westward toward Asia and Australia. This causes cooler, deeper waters to rise along the coast of the Americas, a process known as upwelling. This isn't just an oceanic effect. It changes the air pressure, cloud formation, and precipitation patterns across the globe. It's like taking a map of global weather and redrawing it. Some regions will experience catastrophic rainfall, while others fall into drought and famine. Storms may appear earlier than expected or strike in completely new places. Wildfires, hurricanes, crop failures, heat waves, floods. And this time, it's all happening on a planet that's already weakened. We're entering La Niña not from a neutral baseline, but from the aftermath of an extremely strong El Niño. Oceans are still holding residual heat. Sea level rise continues. Glaciers are retreating at record speeds. And the atmosphere itself is holding more moisture than ever before. According to NASA's latest Earth observatory data, the contrast between cooling eastern Pacific waters and warm western Pacific waters is at its most extreme in over a decade. This east-west heat imbalance creates a sharp gradient that supercharges the Walker circulation, throwing atmospheric currents into chaos. And the question scientists are asking now is, how much worse can it get? We've seen what La Niña can do, but this one may push us into uncharted territory. In the next chapter, we'll explore what this means for specific regions, from floods in Southeast Asia, to drought in the Americas, to hurricanes in the Atlantic that could threaten millions. What's coming next may surprise you. Now that La Niña has returned, one question becomes urgent. What will it do to the world in 2026? The answer depends on where you live, because La Niña doesn't affect every region the same way. It reshapes the entire planetary climate, but its fingerprints are uneven. Some places will drown, others will burn. Let's begin with North America. In the northern United States and Canada, La Niña tends to bring colder than average winters and above average precipitation. Snowstorms in the Rockies and the Great Lakes could hit harder and earlier. Blizzards may sweep across the Midwest with more intensity than usual, but go south, and the opposite happens. California, Texas, and much of the southwestern U.S. may face warmer and drier conditions. In 2020 and 2021, La Niña was linked to the worst wildfire seasons in California's history. Forests were dry, winds were strong, and millions of acres burned. Now in 2026, with similar conditions forming again, officials are already issuing early fire season warnings. Meanwhile, across the Atlantic, something else is building. La Niña reduces wind shear over the tropical Atlantic Ocean, creating the perfect environment for hurricane formation. In 2020, La Niña helped fuel 30 named storms, a record-breaking season. Now, in 2026, NOAA has already predicted an above-average hurricane season, with the potential for more frequent and more intense hurricanes slamming into the Caribbean and southeastern U.S. This means cities like New Orleans, Miami, and San Juan are at heightened risk, and coastal infrastructure, already stressed by rising seas, may not be ready. Now let's turn to Asia and Oceania. In Australia, La Niña is historically tied to massive rainfall and flooding. The 2010 to 2011 La Niña event caused the Brisbane floods, displacing tens of thousands of people. In 2022, another La Niña drenched the eastern coast for months, triggering mudslides and wiping out entire rural towns. In Indonesia, the Philippines, and Thailand, heavy rains are expected again in 2026. This increases the risk of landslides, crop loss, and infrastructure collapse, especially in vulnerable mountain regions. Meanwhile, in East Asia, particularly southern China and Japan, weather patterns will shift toward wetter conditions. Monsoon rains could intensify, bringing flash floods and impacting food production. Across the Indian Ocean, the effects are mixed. East Africa, especially Kenya, Ethiopia, and Somalia, may suffer severe drought, a repeating pattern with La Niña. From 2020 to 2022, East Africa experienced its worst drought in 40 years, putting over 20 million people at risk of famine. Now, with another La Niña unfolding, relief agencies are already preparing for water scarcity and food shortages. But in West Africa, the outcome could be the opposite. Stronger monsoon rains may return, boosting crop yields in some regions, but also raising the risk of flooding and cholera outbreaks, as sanitation systems are overwhelmed. What about South America? Ironically, La Niña tends to dry out the Amazon, one of Earth's most vital ecosystems. Drought in this region doesn't just kill trees, it releases massive amounts of carbon into the atmosphere, accelerating climate change. In 2021, a strong La Niña coincided with a fire season that destroyed more than 5,000 square kilometers of rainforest. And 2026 may bring a repeat of that devastation. In Argentina, Uruguay, and southern Brazil, La Niña has historically reduced rainfall during key planting seasons. That means potential agricultural losses, rising food prices, and economic strain. And then there's Europe. While it sits far from the Pacific, Europe is not immune. During La Niña, colder winters often strike Central and Western Europe, including Germany, France, and the UK. Energy demands rise, roads freeze, crops struggle. Southern Europe, like Spain and Italy, may see less rainfall, intensifying droughts that have already plagued the region for years. Scandinavia and parts of Eastern Europe, on the other hand, may see increased snowfall and colder temperatures. And globally, the interconnected impacts continue. The Panama Canal, which depends on steady rainfall to function, saw record delays during the last ENSO cycle. Now, with rainfall projected to drop again, global shipping may be disrupted, affecting supply chains from Asia to the Americas. Agricultural commodity prices, insurance premiums, tourism flows, even political stability in fragile regions all could be influenced by what La Niña does next. Because make no mistake, this isn't just about the weather, it's about the world economy, food security, human survival, and the regions that adapt best will be the ones that understand the patterns before they strike. In the next chapter, we'll look below the surface, into Earth's oceans, and see how marine ecosystems, Fisheries and coastlines are already being reshaped by La Niña's cold touch, while most eyes are on storms, droughts, and floods. Beneath the surface, a quieter crisis is unfolding, one that affects every breath we take and every bite of food we eat. Because La Niña doesn't just reshape the skies, it rewires life in the oceans. As cooler waters rise in the eastern Pacific, the process of upwelling intensifies. This brings nutrient-rich deep water to the surface, fueling explosions of phytoplankton, the microscopic plants that anchor the entire marine food web. In the short term, this seems like a good thing. Fisheries in places like Peru and Ecuador may thrive for a while, but the balance is fragile because La Niña also disrupts the natural flow of ocean currents, causing some species to migrate unexpectedly or even vanish. Fish that once fed coastal economies can move hundreds of miles away. Others may die off if the water becomes too cold, too fast, and the ripple effect is enormous. In the 2010 to 2011 La Niña event, sardine and anchovy populations collapsed off the coast of Chile, disrupting entire communities. Now, in 2026, similar signals are emerging: mass strandings, shifting migratory routes, and early signs of ecosystem stress in the Pacific and Indian Oceans. Then, there's the coral. Unlike El Niño, which brings devastating heat stress, La Niña brings temperature volatility. Some reefs may find temporary relief from bleaching, but others, especially in the western Pacific, may face cold shock, high salinity, and even reduced light levels from increased rainfall and sediment runoff. According to a 2024 report by the Australian Institute of Marine Science, coral reefs around Papua New Guinea and the Solomon Islands are already showing signs of stress-related bleaching, even in cooler waters. And it doesn't end in the sea. La Niña also strengthens dust transport from Africa to the Americas. That dust travels across the Atlantic and settles over the Amazon rainforest, where it acts as both fertilizer and threat. In the wrong balance, this dust can damage cloud formation, block solar radiation, and trigger complex feedback loops in the local climate. Even the rainforest feels La Niña's breath. Ecosystems, on land and sea, are not just responding to the planet's new rhythms. They're adapting, struggling, or collapsing under the weight of change. And the consequences will echo far beyond the coastline. In the next chapter, we'll explore how climate change is twisting this natural cycle, making La Niña events more extreme, more frequent, and far more unpredictable. So far, we've looked at La Niña as a natural cycle, part of a rhythm Earth has followed for thousands of years. But what happens when that rhythm is thrown off balance? That's exactly what's happening now, because in 2026, La Niña isn't operating in a stable climate. It's unfolding in a world that's warming fast. Since the Industrial Revolution, human activity has added more than 1.5 trillion tons of CO2 into the atmosphere, and that's changing everything. According to the IPCC's 6th assessment report, global surface temperatures have already risen by 1.2 degrees Celsius, and the oceans have absorbed over 90% of that excess heat. This matters because ENSO is powered by ocean heat, and when that heat rises, the engine gets stronger and more erratic. Recent studies, including a landmark 2023 paper published in Nature Climate Change, suggest that extreme El Niño and La Niña events may double in frequency by the end of this century. That means the once-in-a-generation ENSO swings we've seen in the past could soon become once a decade or even every few years. But frequency isn't the only concern. Intensity is also rising. Researchers from the University of Hawaii have observed that La Niña events in recent decades are cooling faster and lasting longer, especially when they follow strong El Niño phases. This is known as the ENSO rebound effect, and it's exactly what we're seeing now in 2026. And there's more. Climate change is shifting the center of ENSO activity westward across the Pacific. That might sound technical, but it's not. It means more densely populated regions like Southeast Asia, the Philippines, and Eastern India will now sit closer to the epicenter of ENSO's most destructive impacts. More people, more infrastructure, more exposure. And because Earth's atmosphere is holding more moisture due to warming, the storms that do form are stronger, wetter, and harder to predict. Even the traditional early warning signs of ENSO, like trade wind anomalies and sea surface temperature readings, are becoming harder to read. The system itself is changing, and this raises one of the most important open questions in climate science today. Is ENSO still a natural cycle, or is it now a hybrid, amplified, distorted, and accelerated by human influence? Scientists don't have a full answer yet, but the trends are clear. ENSO is intensifying, climate extremes are escalating, and feedback loops between oceans, clouds, forests, and ice are accelerating. What used to be a pendulum has become more like a wrecking ball, and the longer we wait to adapt, the harder it will be to keep up with the next swing. In the final chapter, we'll explore whether anything can be done, what we can learn, how we can prepare, and what the planet is trying to teach us before it's too late. We can't stop La Niña. We can't calm the Pacific Ocean or force the trade winds to change direction. But what we can do is prepare. The first and most powerful tool we have is information. Today, a global network of satellites, ocean buoys, and climate models is constantly tracking sea temperatures, wind shifts, and cloud patterns. We can now detect the early signs of ENSO events months in advance. This early warning system has already saved lives. In 1997, El Niño caught the world off guard. In 2015, thanks to better forecasting, dozens of nations prepared in advance, reducing damage and casualties. But prediction is only half the battle. We also need resilient infrastructure. In places like Bangladesh, low-cost cyclone shelters and elevated homes have dramatically reduced deaths from storm surges. In Peru, early planting strategies and crop diversification are helping farmers withstand rainfall swings caused by ENSO. And in the U.S., cities like Miami and Houston are reinforcing flood defenses and expanding early evacuation protocols. These aren't future concepts. They're real solutions, already working. Then there's the human side. Education, awareness, local adaptation. In 2022, when La Niña triggered deadly droughts in the Horn of Africa, it wasn't just aid agencies that made a difference. It was local communities building water reservoirs, switching crops, and sharing traditional knowledge. Climate resilience isn't just about high-tech satellites or global agreements. It's about what happens village by village, city by city, coast by coast. Because ENSO will continue. La Niña will return again. But we don't have to be caught off guard. The more we understand these natural rhythms, the better chance we have of living with them, not against them. And the more we listen to what the Earth is trying to tell us, the better prepared we'll be for what comes next. La Niña is not a villain. It's not a mistake. It's part of a living, breathing Earth, one that has always shifted, pulsed, adapted. But something is different now. The cycles are faster, the impacts stronger, The signals louder. It's as if the planet is trying to warn us, trying to say, pay attention, I'm changing. Are you ready? Because this isn't just about the Pacific Ocean or rain in Asia or drought in Africa. It's about the fragile thread that connects all of us, from farmers in Peru to families in Florida to fishermen in the Philippines. The weather we feel is shaped by forces we cannot see. But understanding them, that's how we gain control. That's how we adapt. And maybe how we survive. If you made it this far, then you're already ahead of most. You're listening, you're learning, and there's so much more still to uncover. So stay curious, and whatever you do, don't miss what's coming next.